I hope all of you are doing good. Let's start today's chapter, quadrilaterals. We know that polygons are simple closed figures made up of line segments. A polygon made up of 3 line segments is called a triangle. A polygon made up of 4 line segments is called a quadrilateral. Okay, the word quadrilateral is derived from 2 words, quadri meaning 4 and lateral meaning side. Thus, a quadrilateral is defined as a closed plane figure bounded by 4 line segments such that no 2 line segments intersect each other except at their endpoints. Now, consider this adjoining figure. Points P, Q, R, S are 4 points in a plane such that no 3 of them are collinear and line segment. Collinear means points which are on the same line. Those points are collinear, but these are not collinear points. And line segments PQ, QR, RS and SP do not intersect except at their endpoints. The figure formed by these 4 line segments is called a quadrilateral PQRS. Okay. Now, elements of quadrilateral. In quadrilateral PQRS, number 1, points P, Q, R and S are called its vertices. 2, the line segments PQ, QR, RS and SP are called its sides. 3, angle SPQ, angle PQR, angle QRS and angle RSP are called its angles, denoted in short as angle P, angle Q, angle R, angle S respectively. 4, the line segments joining the opposite vertices, that is PR and QS are called its diagonals. Thus, a quadrilateral has 4 vertices, 4 sides, 4 angles and 2 diagonals, right? Adjacent sides. 2 sides of a quadrilateral having a common endpoint are called its adjacent sides. Thus, in this figure, PQ and QR, QR and RS, RS and SP, SP and PQ, these all are adjacent sides, okay? Opposite sides. 2 sides of a quadrilateral are called its opposite side if they do not have a common endpoint. In the figure, PQ and RS, PQ is opposite to RS, RQ is opposite to SP or PS, okay? Adjacent angles. 2 angles of a quadrilateral having a common side are called its adjacent angles. In the figure, angle P, C, angle P and angle Q, these are adjacent angles. Angle Q and angle R, these 2 are adjacent angles. Angle Q and angle S, these are adjacent angles. And angle S and angle P, these are adjacent angles, okay? Opposite angles. The angles on the opposite vertices of a quadrilateral are called opposite angles of the quadrilateral. This angle P and angle R and angle Q and angle S are 2 pair of opposite angles, okay? Now, consider this given figure. ABCD is a figure obtained by joining 4 line segments. However, it is not a quadrilateral since these line segments intersect at points other than their endpoint. Okay. Now, interior and exterior of a quadrilateral. Consider the given figure. The quadrilateral PQRS divides all the points of the planes into 3 parts. Number 1, the part of the plane made up by all points such as A, B, C. These points, okay, A, B, C. These are inside the quadrilateral PQRS and is called the interior of the quadrilateral. Number 2, the part of the plane made up of all points such as L, M, N. L, M, N. Okay, these points are outside the quadrilateral. That's why these are called the exterior of this quadrilateral. And 3, all points such as X, Y, like this X, Y, Z. Okay. Which lie on the quadrilateral PQRS itself. Note, quadrilateral PQRS is the boundary of its interior. Okay, the interior of quadrilateral PQRS along with the boundary is called the quadrilateral region. 2 types of quadrilaterals. Number 1, convex quadrilaterals. A quadrilateral in which the measure of each angle is less than 180 degree is called a convex quadrilateral. Remember this. In a convex quadrilateral, the line through any 2 of its vertices has the remaining vertices on the same side of it. In our discussion, by a quadrilateral, we mean a convex quadrilateral. 2, a quadrilateral in which the measure of at least one of the angles is more than 180 degree is known as concave quadrilateral. While the diagonals of a convex quadrilateral lie completely in its interior, in case of a concave quadrilateral, one diagonal lies in the exterior of the quadrilateral while the other lies in its interior. Okay. Next, angle sum property of a quadrilateral. The sum of the angles of a quadrilateral is 360 degree or 4 right angles. Proof. Consider the quadrilateral PQRS. Draw a diagonal PR. Now, as you can see, we have 2 triangles. We know that the sum of angles of a triangle is 180. So, in PQR, angle 2 plus angle 3 plus angle Q is equals to 180 degree, and in PRS is angle 1 plus angle 4 plus angle S is equals to 180 degree by angle sum property. Okay, and on adding the angles on either side, we get angle 2 plus Q, angle Q plus angle 3 plus angle 1 plus angle 4 plus angle S is equals to 180 plus 180, that is 360 degree. Okay, that means angle P, angle Q, angle R plus angle S is equals to 360 degree. So what we conclude from here, that sum of the interior angles of a quadrilateral is 360 degree. Okay. Now, interior and exterior angles of a quadrilateral. The angles of a quadrilateral are called its interior angles. If the exterior angles of a quadrilateral are produced in order as shown in the figure, then angle 1, angle 2, angle 3 and angle 4 are called the exterior angles of the quadrilateral. Okay, as you can see, these are the exterior angles. Okay, exterior angle sum property. If the sides of a quadrilateral are produced in order, the sum of the 4 exterior angles so formed is 360 degree. Proof. Consider a quadrilateral ABCD. Let its side be produced in order, forming exterior angles 1, 2, 3 and 4 as shown in the above figure. We know that the sum of the angles of a linear pairs is what? 180 degree. So hence in the figure, angle 1 plus angle A is equals to 180 degree, angle 2 plus angle B 180 degree. Similarly, angle 3 plus angle C is equals to angle 3 plus angle C is equals to 180, angle 4 plus angle D is equals to 180. And on adding these angles, that is angle 1, angle 2, angle 3, angle 4 plus angle A plus angle B plus angle C plus angle D, we get 720. Okay, but angle A, angle B, angle C and angle D means on adding all these 4 angles, we get 360 degree. So angle 1 plus angle 2 plus angle 3 plus angle 4 is what? 720 degree minus 360 degree is equals to 360 degree. That means the sum of the exterior angles of a quadrilateral is also 360, right? Example 1. In a quadrilateral, the angles are in the ratio 1 is to 2 is to 4 is to 5. Find the angles. Okay. So we will let the measure of angles be x, 2x, 4x and 5x. Okay, so x plus 2x plus 4x plus 5x is equals to 360 degree. 9, 11, 12. 12x is equals to 360 degree and x is equals to 360 upon 12. That is 30 degree. So the value of x is what? 30 degree. 2x is 2 into 30, that is 60 degree. 4x is equals to 4 into 30, that is 120 degree. Okay, and 5x is equals to 5 into 30, that is 150 degree. So these are the 4 angles: 30 degree, 60 degree and 120 degree and 150 degree, right? Exercise 21.1. A quadrilateral has dash vertices. A quadrilateral has 4 sides, that means it has 4 vertices. A quadrilateral has dash sides, 4 sides. Okay. Now, type of quadrilaterals. In this section, we shall define various types of quadrilaterals. They are: number 1, trapezium. A quadrilateral having exactly one pair of parallel sides is called a trapezium. Okay. See, this is the trapezium. Now, we will consider this figure. AB, this side is parallel to this side. That is, AB is parallel to CD. Hence, it is a trapezium. If the non-parallel sides of a trapezium are equal, then it is called an isosceles trapezium. Hence, quadrilateral ABCD will be an isosceles trapezium if these 2 sides are parallel and these 2 sides are equal, right? Number 2 is parallelogram. A quadrilateral with its both pairs of opposite sides parallel is called a parallelogram. Consider the figure ABCD. It is a parallelogram because AB is parallel to DC and AD is parallel to BC. Okay, the figure is given on the next page. See, AB is parallel to CD, AD is parallel to BC, right? Number 3 is rhombus. A parallelogram having all sides equal is called a rhombus. Thus, parallelogram ABCD is a rhombus if AB is parallel to CD and AD is parallel to BC and also all 4 sides are equal, then it is a rhombus. Okay. Number 4, rectangle. A parallelogram whose each angle is a right angle is called a rectangle. Consider the figure ABCD. It is a rectangle because AB is parallel to CD. AB is parallel to CD. AD is parallel to BC and angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degree. Number 4, square. A square is a rectangle with a pair of adjacent sides. Consider the figure ABCD. It is a square in which AB is parallel to DC and AD is parallel to BC. And all 4 sides are equal, and also all 4 angles are 90 degree. Okay. 6, kite. A quadrilateral is a kite if it has 2 pairs of equal adjacent sides and unequal opposite sides. Thus, a quadrilateral ABCD is kite if, see, if AB is equals to AD and BC is equals to DC, but AD is not equals to DC and AB is not equals to BC, right? Now, properties of parallelogram. Following are the properties of a parallelogram. Number 1, each diagonal divides it into 2 congruent triangles. Okay. 2, the opposite angles are equal. 3, the opposite angles are equal. Sides are equal and opposite angles are also equal. 4, the diagonals bisect each other. Okay. Now, proof. Consider a parallelogram ABCD. Now, we will draw a diagonal AC. So, we get 2 triangles as triangle ABC and triangle CDA. We have angle 1 is equals to angle 2, alternate angle. Angle 2 is equals to angle 4, alternate angle. AC is common side. AC is common in both these triangles. Okay. So, these 2 triangles are congruent by ASA, that is angle side angle property. Now, their corresponding sides and angles are also equal. Therefore, AB is equals to DC and BC is equals to AD. And angle B is equals to D. Similarly, by joining vertices B and D, we can prove that triangle ABD is congruent to triangle BCD. From this, we get angle A is equals to angle C. This proves the statements 1 and 3, which is that each diagonal divides into 2 congruent angles, and number 3 is the opposite angles are equal. Okay. To prove the 4th statement, we proceed as follow. Draw both the diagonals cutting each other at O, like this. Okay. Now, in triangle OAB and OCD, angle DCO is equals to OAB, alternate angle, DOC, this angle, and angle AOB, this angle. These 2 angles are vertically opposite angles, right? And angle CDO is equals to angle ABO, third angle, and AB is equals to DC. How? We have proved this earlier. Therefore, angle DOC, triangle DOC is congruent to triangle AOB by ASC property. Therefore, DO is equals to OB and OA is equals to OC. Thus, the diagonal bisect each other. Note, since a rhombus, a rectangle and a square are special type of parallelograms, all the properties of a parallelogram are satisfied by each one of these. The converse of the above properties of a parallelogram is true. That is, a quadrilateral is parallelogram if its opposite sides are equal, its opposite sides angles are equal, its diagonals bisect each other, and it has 1 pair of opposite sides equal and parallel. Next, diagonal property of a rhombus. The diagonals of a rhombus bisect each other at right angles. Proof. We know that a rhombus is a parallelogram and the diagonals of a parallelogram bisect each other. Now, consider the rhombus ABCD. Draw its diagonal to intersect at O. In triangles COD and COB, we have OC as the common side. OC is equals to OC, right? DC is equals to BC, side of a rhombus, and OD is equals to OB because O is the midpoint of BD and OC is the common side. Now, by SSS property, these 2 triangles are congruent to each other and their corresponding angles are equal. So, angle COD is equals to angle COB is equals to 180 by 2, that is 90 degree. And angle COD plus COB is a linear pair. Hence, the diagonals of a rhombus bisect each other at right angles. Okay. Diagonal property of a rectangle. The diagonals of a rectangle are equal. Proof. Consider rectangle ABCD, draw its diagonals AC and BD. Consider triangle ABC, this one, ABC and ABD, this one. Okay. This. Now, we have AB is common, angle BAD is equals to ABC 90 degree, AD is equals to BC. Now, by SAS, both these triangles are congruent and therefore BD is equals to AC. That means diagonals of a rectangle are equal. Next, diagonal property of a square. The diagonals of a square are equal and they are bisect at right angles. Proof. We know that the diagonals of a rectangle are equal, but every square is a rectangle. Hence, the diagonals of a square are equal. Besides, the diagonals of a rhombus bisect each other at right angles, but every square is a rhombus. So, the diagonals of a square bisect each other at right angles. Note, if the diagonals of a quadrilateral are equal, it is not necessarily a rectangle. And number 2, if the diagonals of a quadrilateral intersect at right angles, it is not necessarily a rhombus. Okay. Example, in the figure ABCD is a parallelogram. If angle A is 80 degree, calculate the other angles. Okay. See, AB, you can see AB is parallel to CD and AD is what? AD is transversal. Therefore, angle A plus angle D is equals to 180 degree. Angle A is given 80 degree. We have to find angle D. So, angle D is equals to 180 minus 80 degree. That is, angle D is equals to 100. Okay. Now, but in a parallelogram, opposite angles are equal. That means opposite of D is what? Angle B. So, angle B is equals to angle D and angle D is equals to 100. That means angle B is 100 degree. And angle C is equals to angle A. So, you will write angle C is equals to angle A and angle A is equals to 80 degree. Okay. Therefore, angle C is also 80 degree. Right. Exercise 21.1. Draw an isosceles trapezium and measure its sides and angles. Okay, you have to draw an isosceles trapezium, then you will measure its sides and angles. Okay. Things to remember. If ABCD are 4 points in a plane such that 1, no 3 points are collinear, and 2, the segments AB, BC, CD and DA do not intersect except at their endpoints, then the figure made up of the 4 segments is called a quadrilateral with vertices A, B, C and D. Number 2, in a quadrilateral ABCD, number 1, A, B, C and D are called vertices. 2, the 4 line segments AB, BC, CD and D are called its sides. 3, the angles having a common arm are called adjacent angles. 4, the line segments AC and BD are its diagonals. 3, a quadrilateral is convex if for any side of the quadrilateral, the line containing it has the remaining vertices on the same side of it. 4, the sum of the angles of a quadrilateral is 360 degree. 5, if the sides of a quadrilateral are produced in order, the sum of the 4 exterior angles so formed is 360. 6, a quadrilateral having exactly one pair of parallel sides is called a trapezium. 7, a quadrilateral with each pair of opposite sides parallel is called a parallelogram. 8, a parallelogram having all sides equal is called a rhombus. 9, a parallelogram with each angle a right angle is called a rectangle. 10, a rectangle with a pair of adjacent sides equal is a square. 11, in a parallelogram, opposite sides are equal, opposite angles are equal and diagonals bisect each other. In rhombus, all sides are equal. Diagonals bisect each other at right angles. In a rectangle, each angle is a right angle, diagonals bisect each other and diagonals are also equal. 14, in a square, all sides are equal in length, each angle is a right angle, the diagonals are equal, the diagonals bisect each other at right angles. Okay. And number 15, a quadrilateral having 2 pairs of equal adjacent sides but unequal opposite side is a kite. Students, now you will do practice of the remaining questions of this chapter.